and welcome to Calculus. In this series, we will be breaking down the various topics which belong in this huge field of mathematics. To begin, let's start by answering a question that many ask. What is calculus? It's a branch of mathematics that helps us understand how things change, whether it's motion, growth, or relationships with quantities. For example, the slope of a hill, or the speed of a car, or how population changes over a period of time. The calculus that we will be dealing with in this series is split into two major categories: differential calculus and integral calculus. The first one deals with rates of change and slopes of curves, while the latter deals with areas and volumes of highly irregular shapes, such as, for example, this one. All this may sound extremely abstract at the moment, however, we will specify it all with examples later on. On the other hand, before exploring calculus, there are some topics that would be beneficial for you to know. This includes rewriting rational exponents. For example, you are given the fourth root of x to the power of 5, and you know that this can be written as x to the power of 5 over 4. Another example could be 1 over x squared, and this can be rewritten as x to the power of -2. Basically knowing that fractions can be rewritten as negative exponents. Of course, it is also crucial for you to know the laws of exponents. I will list the most important ones on the screen as a refresher. These laws include the product law, quotient law, power of a power, the zero exponent law, and products of powers. Another topic that is good to know and you should be familiar with is sketching functions. Up to this point, you should know how to sketch quadratic functions. As an example, let's say we are given a quadratic function, x squared minus 6x plus 7. You should know that the first step to sketching this function would be to find the axis of symmetry and the vertex. We can find it using a well-known formula, x equals to -b over 2a. In our case, that would be x equals to negative of -6 over 2 times 1. That is simply positive 6 over 2, which in the end is equal to 3. So our axis of symmetry is at x equals to 3. This is also the x value of our vertex. So in order to find the corresponding y value, all we have to do is plug in the 3 into the function, so calculating f of 3. That would be 3 squared, which is 9, minus 6 times 3, 18, and plus 7. Some basic arithmetic tells us this is equal to -2. So our vertex stands at 3 and -2. Next up, we know that in order to sketch a parabola, we need at least 3 points. We have the vertex, so that means we just have to find 2 other points. Therefore, we build a little t-table. Here, we can just plug in any 2 x values. Let's say I plug in x equals to 0. The corresponding y value would be 7. And let's say I put in 6, then the corresponding y value is also 7. This can happen because a parabola is always symmetric. Now that we have the axis of symmetry and 3 points and the vertex, let's go ahead and sketch this parabola. At x equals to 3, we have the axis of symmetry. And lastly, all we have to do is plot the 3 points. Here they are, and all we have to do is connect them. And voila, there we have our rough sketch of the quadratic function. Lastly, another topic that you should know would be trigonometry. This includes knowing the trigonometric ratios, sine x, cosine x, tangent x. And of course, you have to know that tangent x is equal to sine of x divided by cosine of x. Other things may include the inverses of trigonometric functions. The inverse of sine is simply the arcsine. Inverse of cosine is the arccosine. And the inverse of tangent is simply the arctan. Another relevant thing would be the reciprocal. 1 over sine is simply denoted as the cosecant. 1 over cosine is the secant, and 1 over tangent is simply the cotangent. Metric ratios, of course, you also need to know the very important and famous trig identities. This includes the Pythagorean identity. This includes sine squared of x plus cosine squared of x is equal to 1. Or 1 plus tangent squared of x is equal to secant squared. Next category would be double angle identities. These include sine of 2x is equal to 2 sine of x times cosine of x. Or that cosine of 2x can be rewritten in 3 different ways. One of them is cosine squared of x minus sine squared of x. Another is that cosine squared of x, 2 cosine squared of x minus 1 can also be written as cosine 2x. And finally, it can also be written as 1 minus 2 times sine squared of x. And finally, the 2 most important, in my opinion, are cosine squared of x can be written as cosine of 2x plus 1 over 2. And sine squared of x can be written as 1 minus cosine of 2x divided by 2. These 2 are extremely important, and I will explain why later on. If you have never heard of these topics, or maybe aren't as comfortable in them as you'd like to be, then don't worry, I have other series for each of them that will be out soon. So now that we have a basic understanding of what we are dealing with here, we will go straight into the first topic of limits in the next video. So I hope to see you there, and have a nice day. Bye!